In this video, we are continuing going over solving rational equations. This is our second day, and with these equations, they're set up a little different than when we talked about solving equations our first day. So notice with these, again, the main thing is always check for the extraneous solutions. So we need to make sure to identify what are those values that make our expression undefined, because then if it is a solution, then we know it's canceled out because it's what makes the expression undefined. Now, notice here in our first example, how we have 18 over x, and we are now subtracting. So we have x minus this rational value here is equal to 3. What I need to do is I need to make sure then, I'm going to focus on if all values have the same denominator, then we can focus on the numerator. So if all values were over x, then that means I could solve this equation because they have the same denominator. So here that means, because if you think about it, right, this is x over 1 and this is 3 over 1. I just need to get to the denominator of x, right? Now, 18 already has, so over x is equal to, still again, everything needs to be over x when solving equations. So not just even adding and subtracting, but even solving. I'm going to go ahead and multiply that first value here of x, or x over 1, by x. And same thing here with a value of 3. I'm going to multiply by x. So now x times x is x squared over x minus our 18x is equal to, here I've got 3 times x, so 3x, and then here's our over x. So basically, if you notice, what we're doing is we're canceling out all of our denominators. So now I'm left with x squared minus 18 is equal to 3x. Now I can go through and solve my equation. We're solving a quadratic here, so that means it has to equal 0 when solving. So I'm going to go ahead and subtract 3x from both sides. Now here I'm going to bring down my x squared. I cannot subtract 3x though from either of these because nothing is like terms. So bring down minus 3x minus 18 is equal to 0. Now we can solve the quadratic. So I'm going to go ahead and set up my factoring since a is equal to 1. And what numbers multiply to get negative 18 and add to get negative 3? Negative 6 and positive 3. That means x is equal to 6 and negative 3. Now I'm going to check before saying that this is my answer. Well, we had x in the denominator, so x alone cannot equal 0. So that is the value that makes us undefined. This is our extraneous. But we got 6 and negative 3, so we're good. Both are a solution. So go ahead and pause the video and try the U-try on your own. So with the U-try, again, you have your rational expression here, 6 over x. So I know with x all by itself in the denominator, that is going to be my extraneous solution. X cannot equal 0. So that is our undefined value here. Now to, again, solve for x, to solve our equation, again, I'm just going to go ahead and multiply now by x. So here I've got x squared over x, right? Because this is x over 1, so multiplying by x, which is equal to 6 over x minus, this is again just x over x, because that's really like 1 over 1 multiplying by x. So really, if you think about it, what we're doing here is we're just multiplying everything by that denominator. So now here I'm left with x squared is equal to 6 minus x. Now I'm solving for x. But notice how, again, we have our quadratic. So I'm going to go ahead to make this 0. I'm going to add x to both sides of my equation. So I've got x squared plus x is equal to 6. Still equal to 6, but it has to equal 0. So I'm now going to subtract 6 from both sides of the equation. Now I've got x squared plus x minus 6 is now equal to 0. Now I can go ahead and solve this quadratic by factoring. So what numbers multiply to get -6 and add to get 1? +3 and -2. That means x is equal to -3 and +2. And I can box both and say both are a solution because 0 was what makes this undefined. So now look at the second example. Here we have two rational expressions, right? Or two rational. We have 3 and x. So really, if you think about it, the denominator that I'm going to need here is 3x, right? So that means if I need 3x in my denominator, that means I need to multiply this first fraction here, 10 over 3 by, well, if it already has 3, then I need to multiply by x. Here, if I already have x in my denominator, then that means I need to multiply 4 only by 3. Now, this is just 2 or 2 over 1. So that means I need to multiply 2 by 3x because it needs both of those values. So now as I go through, here I've got 10 times x, which is 10x. That is equal to 4 times 3, which is 12, plus 2 times 3x, which is 6x. Now notice in the end, right, if you think about it, everything is over 3x. So that's why here, so like for example, here I had all over x canceling out. So now I'm left with my numerators. Here we had all x in our denominator, so I focus on my numerators. So in the end, we have 3x in our denominator once we have our equation here. So they all cancel out, so I'm focusing just on the numerator. Now I just solve for x. But before I do that, let me go back to our original here. Notice how we had x alone in the denominator. So x cannot equal 0. Now I'm going to go through and just solve for x. Now this is just a normal linear equation. So I'm going to subtract 6x from both sides. I'm going to gather my variables here. Now I've got 4x is equal to 12. Now just solve for x and divide by 4. Here I've got x is equal to 3, which can occur because x cannot equal 0. So go ahead and pause the video and try this try on your own. And in this example, I notice I have x, 4, and 4 all in my denominator. That means the common denominator that I need to focus on here is 4x. So you should have focused on 4x being that common denominator. So that means in order to cancel these values out, the denominators out, we need to get that common denominator. So that means here, if you have 6 over x, then you should have multiplied 6 by 4. Here, if I have 5 over 4, then you should have multiplied 5 by x. And the same thing here. If I have -7 over 4, then you should have multiplied -7 here by x as well. So that's here what was missing. Now I'm going to go ahead and write this out. But before I do, here I've got x in my denominator. So x again cannot equal 0. So now 6 times 4 is 24 plus 5 times x, 5x, which is equal to, that is a -7 times x, -7x. Now I'm going to go through and solve my linear equation. I'm going to gather the variables. So here I'm going to subtract 5x from both sides of my equation. Now I have 24 is equal to -12x. Still multiplying x by -12, so divide by -12. And you should have gotten x is equal to -2. And x can equal -2 because it is not our extraneous solution. So here, that's how you would solve that try. Now, example 3, just mixing things up. We're going back to kind of like what we did in the first day. So how did we solve if we had these two ratios here, if we had like a proportion? You can cross multiply. So before I do that, I notice I have two different denominators, right? So again, notice how we have x plus 3. So that means x cannot equal -3 and +3. So keep in mind now, though, we have two values that x cannot equal. So keep that in mind as well. So I'm going to go ahead now and cross multiply. So I'm going to multiply x minus 5 times x minus 3. That is equal to, here, cross multiply, 2 times x plus 3. So now notice, what do you have here on the left side? Well, now I have my two binomials, so we have to do FOIL, or you can do box method, area model. So I'm going to go ahead and set it up and multiply. So here, x squared, negative 5x, negative 3x, and positive 15. When you combine like terms, here, negative 3x plus 5x is negative 8x. So now here I've got x squared minus 8x plus 15. That is equal to, now that's just 2 being distributed, 2x plus 6. Again, notice how we are solving a quadratic, and quadratics have to equal 0. So I'm going to subtract 2x from both sides. Notice how I'm just lining up my like terms here. I'm going to also go ahead and subtract 6. Again, line up the like terms here. So now both cancel out. There's my 0. And here I have x squared minus 10x plus 9. Now I'm going to go through and factor. What numbers multiply to get positive 9 and add to get negative 10? Negative 9 and negative 1. So that means that x is equal to positive 9 and positive 1. And now, are either of these values extraneous? No. Our values that would make this undefined were -3 and 3, so we're good. Both 9 and 1 are a solution. So go ahead and pause the video and try the U-try on your own. With this problem, I'm going to again focus on the extraneous first because I notice here I have both different values. So here in this case, x cannot equal, so from this expression here, x minus 4 cannot equal 0, so x cannot equal 4. And from x minus 2, which cannot equal 0, that means x can also not equal 2. So both values would make this expression undefined. So these are our extraneous. Now I'm going to go through and solve. I notice I have my proportion. I have like two ratios here. So cross multiply. So here I have x times x minus 2, which is equal to, again, cross multiply. So this is x plus 10 times x minus 4. Now on the left side, you're just multiplying or distributing x because it's just the one term. So I've got here x squared minus 2x. That is equal to, now on the right side, we do have two binomials being multiplied together. So this is FOIL, or I'll go ahead and set up box. So x plus 10 times x minus 4. Here x squared and x, negative 4x, and negative 40. Then combining like terms, 10x minus 4x is now 6x. So you should have here x squared plus 6x minus 40. Now we're going to go through and solve for x. Now one thing I notice is we have a quadratic, but we have x squared on both sides. So if you notice, let's just say I want to gather. Well, if they're on both sides and I want to subtract x squared to gather, well, what happens? That is 0, and this is also 0. So really, being on both sides, they end up canceling out. So I'm going to bring down negative 2x, which is equal to 6x minus 40. Now I'm ending up really just solving a linear equation. I'm going to gather my variables, so I'm going to subtract 6x from both sides of my equation. Here now you have negative 8x is equal to negative 40. Then divide both sides by negative 8. You should have gotten x is equal to positive 5. Now, before we say that x is equal to 5 is our answer, is it an extraneous solution? No, 4 and 2 were. So x is equal to 5. That is our solution. With our last example and you try here, now notice we are subtracting. Look at the denominators. Always look at the denominators. So here I've got p plus 3, p minus 3, and p squared minus 9. So notice how we're subtracting these two fractions and it's equal to p squared minus 9. Well, I notice if I were to factor, let's say, p squared minus 9, p squared minus 9 factored is p plus 3 times p minus 3. So if this is p squared minus 9 in factored form, now look back. Well, here's p plus 3. What's missing? P minus 3. Here's p minus 3. What's missing? P plus 3. So the same thing here to get that common denominator. I'm going to multiply the first rational expression by p minus 3. Then here I'm going to multiply the second rational expression here, but by p plus 3. So now I can get that common denominator. And then of course here we've got that p plus 3 times p minus 3 already, so no need to multiply 7 minus 3p. So here I've got I put p plus, p minus 3 times p minus 1. Keep in mind, now we do have the box method. So instead of just multiplying or distributing, I'm going to go ahead and set up that box here, or you can do FOIL. Oh, and then I just realized something. My fault, guys, as I just got right into solving, I forgot to identify my extraneous. So P cannot equal. Well, here we've got positive 3 and negative 3, if you think about it, right, in our denominator. So P cannot equal negative 3 and positive 3. So keep that in mind. That's your extraneous. Now I'm going to go ahead and continue and do FOIL, or here I'll set up box method. So P minus 3 times P minus 1. P squared, negative 3P, negative 1P, and positive 3. So when you combine negative 3p plus another negative 1p, now you have negative 4p. So that first portion here, we have p squared minus 4p plus 3. Then minus, right? So we have minus. Now I've got here 2p, 2 times p plus 3. So we're just distributing 2 here. So here I've got 2p plus 6 is equal to 7 minus 3p. Now, before we continue and start combining like terms, notice it is so important and key, guys, here when you're subtracting, if you have subtraction, make sure to distribute the negative or negative 1 here. So before we start combining like terms, because this was subtraction, now make sure to distribute. So now I've got p squared minus 4p plus 3, but now minus 2p minus 6. That is equal to 7 minus 3p. Now I'm going to go ahead and combine like terms, negative 4p and negative 2p, so p squared minus 6p. You also have 3 minus 6, which is negative 3. That is equal to 7 minus 3p. Again, we are solving a quadratic. Notice how we have p squared. So I need this to equal 0. So I'm going to subtract 7, but line it up and add 3p. Again, line up your like terms. So everything cancels out here, and I've got p squared minus 3p minus 10. Now I'm going to go through and solve by factoring. So what numbers multiply to get negative 10 and add to get negative 3? Negative 5 and positive 2. That means P is equal to positive 5 and negative 2. Now, before we say that these are both our answer, let's check for the extraneous. Negative 3 and positive 3, so we're good. Both 5 and negative 2 are a solution. So go ahead and pause the video and try this try on your own. With our last problem here, I'm going to notice that I could factor this denominator. So if I were to factor this denominator, I would have x plus 3 times x minus 2, because these two factors here multiply to get negative 6 and add to get 1. That means here, if this was my denominator, then I have x minus 2 here, so I could multiply the first rational expression by x plus 3. Then if I have x plus 3 here, then I multiply the second expression here by x minus 2. Then now I've got my common denominator. That means here for our undefined, x cannot equal negative 3 and positive 2. So keep that in mind. That's your extraneous solutions here. So now I'm going to go ahead and start continuing on. So you should have distributed x here. So x times x is x squared. X times 3, 3x. Now we are just adding, so I'm going to go ahead now and distribute this value here. So 2 times x, 2x, 2 times negative 2, negative 4. That is equal to 3x plus 4. Now I'm going to go ahead. I notice on the left, you have like terms here to combine. 3x plus 2x. So x squared plus 5x minus 4 is equal to 3x plus 4. And again, you're solving a quadratic, right? Here I've got x squared, and it has to equal 0. So moving over 3x, line up the like terms, and also subtract 4. Now I've got x squared plus 2x from 5x minus 3x minus 8. Negative 4 minus 4, negative 8. Now we can solve by factoring. What numbers multiply to get negative 8 and add to get 2? Positive 4 and negative 2. That means x is equal to negative 4 and positive 2. Now, before I say this is my answer, let's check for the extraneous. Here we said our undefined values, extraneous solutions were negative 3 and 2. Oh, notice how 2 was extraneous. So what does that mean here about 2? Can 2 be a solution? No, because that would make this expression undefined. So the only answer that this equation has is negative 4. Now, this was our last try. However, if you tried this extension problem, I'll go ahead and go over it, but go ahead and pause the video, try this, and then let's see what you get. I notice in the expression here in the denominator, we have a trinomial. So I'm going to see about factoring this and seeing if it shares these same factors here. What multiplies to get positive 15 and adds to get negative 8? Negative 5 and negative 3. So that means I do have these two values here. So I'm going to go ahead and focus on this in my denominator. So before I continue, let's identify the extraneous solution. So x cannot equal positive 5 and positive 3. So keeping that in mind. Now I'm going to go ahead and continue solving this problem because it said that Misty solved this and found the solutions of 1 and 3, but which are true. Now we're already saying that 3 cannot be a solution because this would make this undefined. But let's just double check and make sure that you get 1 and 3 here, like what Misty did, so that we can agree that 1 could be a solution, but 3 is our extraneous. So I'm going to go ahead and multiply the first irrational here. If it already has x minus 5 in the denominator, I'm going to multiply by x minus 3. Then here, if we already have x minus 3 in our second rational expression here, I'm going to multiply by x minus 5. The negative 6 already has the common denominator that we're focusing on with both factors. So, well, 1 times x minus 3. Well, that's just going to stay as x minus 3. However, here you are distributing x, and that's we're adding. So again, staying positive, so x squared minus 5x. X times x is x squared, and x times negative 5x is equal to negative 6. Now, I notice we do have like terms, so I'm going to also rewrite this in standard form. So I'm going to put x squared first. So x squared, but now you have 1x, right? So 1x minus 5x, negative 4x, minus 3 is equal to negative 6. Now again, our quadratic when solving always has to equal 0. So make sure to add 6 here now to both sides. Now I've got x squared minus 4x plus 3. Now solving by factoring. What numbers multiply to get positive 3 but add to get negative 4? Negative 3 and negative 1. So that means x is equal to 1 and 3. Now, here we go. So that's what Misty got, 1 and 3. However, 3 is extraneous. So that means 3 is extraneous, so it cannot be a solution, but 1 is a real solution. So that's why the answer is A.